Today we discuss microwave engineering. In the previous class, we discussed about introduction of microwave. In the introduction part, we discuss about what is the frequency of microwave. Microwave frequency is like from 300 megahertz to 300 gigahertz, and we also discuss microwave frequency range for different application in term of microwave ovens, in term of radar, in term of healthcare application we also use. And this is also the microwave frequency range spectrum we also divided in the different way, means IEEE divided in term of S band C. Yeah, the frequency band is also divided, means microwave frequency range is also divided in SCXKUK band. And we also discussed all these things in the previous slide, previous classes. We discussed the microwave frequency range. Microwave frequency spectrum is for gamma, HX means hard X-ray, and X-ray is also used for different application. Visual frequency spectrum are given here, visual frequency band, and microwave frequencies are given here. Microwave frequencies, these are the microwave frequencies. These are the microwave frequencies, means extremely high frequencies, super high frequency, ultra very high, and these are the different frequencies, microwave frequencies. And these are the ultra wide band, super ultra low frequency, super low frequency, extreme low frequency also given here. And the microwave spectrum are given here, as you can see. We also discussed this in the previous classes. These are the microwave frequency band in terms of LSCS, KUK, LSCS, KU, LS frequency band 1.1 to 1 gigahertz to 2 gigahertz, S band 2 to 4 gigahertz, C band 4 to 8 gigahertz, X band 8 to 12 gigahertz. And these are the KU band, is also important. And there are B band, W, X band, and D band. The other frequency of this band 50 gigahertz to 75 gigahertz, 75 to 110 gigahertz, 90 gigahertz to 140 gigahertz, 110 to 170 gigahertz. Advantage of microwave. What is the advantage? We also discussed in the previous slide, previous classes. Means it having the largest bandwidth, better directivity, and a smaller size antenna. As we know that frequency increases, the size of antenna decreases. It depends on the size of antenna. It depends on wavelength. Wavelength is depends on frequency, means lambda. Lambda equal to wavelength. C by F. Lambda means wavelength. This one is the wavelength, this one is the frequency. As we go toward the higher frequency, then the size of lambda is decrease, means inversely proportional to each other. As we increase the frequency, the size of lambda is decrease. As the size of lambda is decrease, then the height of antenna is decrease. The size of antenna depends on lambda. Size of antenna depends on lambda. Suppose this one is the antenna and this one is the lambda. Then as frequency increase, this one is frequency increase, then lambda is decrease. As lambda decrease, as lambda is decrease, the height of this one is equal to the height of antenna is decrease. And the low power consumption, as microwave frequency is having low power consumption. And effect of fading, this one, effect of fading. The effect of fading is minimized by using the line of sight propagation technique, as we discussed in the previous classes. This one with the means line of sight, means these are the line of the other antenna. This one is the antenna. Both are the line of sight. Okay. Application of microwave. There are different applications of microwave, as we discussed. Means we can use microwave for the communication, remote sensing, heating, and medical science application. Communication, in terms of communication, microwave link are used for microwave link in use for BTS. BTS means tower jet, mobile tower. In the mobile tower, microwave antenna is used to communicate, used for the communication purpose. And and in terms of remote sensing, as you can see the next slide, communication microwave is used in broadcasting and the telecommunication transmission. As you can see here, in terms of communication, microwave is used broadcasting and transmission. And I described above, there are the short wavelength, means microwave having the small wavelength, allow to use a small size antenna, as we discussed previous. Means as the frequency increase, the size of lambda decrease, then the size of antenna is decrease. Means antenna, lower size antenna, small size antenna. And cellular network use GSM also uses, and for the GSM mobile phone, we also use micro frequencies. And micro frequency is range is 1.8 to 1.9 GHz for communication. And as we know that for the 2G frequency band, 2G frequency means in mobile phone, 2G frequency band are 1800 also used for mobile phone application, and 1900 are used for the 4G frequency, 4G mobile phone application. And microwave are also used. This one, microwave frequency are also used for transmission and reception of signal from Earth to satellite and from satellite to the Earth. Means microwave frequency can be also used for the Earth to satellite and satellite to Earth communication. And it is also used for military application in terms of radar and missile, communication, and for radar also use higher frequencies band, and means X band and Ku band. There we can also use micro frequencies. Remote sensing. In terms of remote sensing, the most of you may be familiar with the application of most common application of microwave is its use in radar and sonar. Micro frequency also used in sonar and radar. Radar is also used to illuminate an object by using a transmitter and receiver to detect its position and velocity. And means with the help of radar we can detect the object, and we not only detect the object, we also found the velocity of the object. We also calculate the position of the object, means given here, position and the velocity. Heating. Microwave also used for the heating purpose. Means with the help of microwave we also cook the food. We can also cook the food just like a micro oven. We can use micro oven to bake and cook the food. It is very convenient electronic machine which perform the heating task very clearly. And very less time. If you want to know how does a microwave works, then you may wonder that it based on the vibration of electron present in the food particles. That is why micro oven heat the food uniformly without heating the container. Means microwave frequencies are vibrate the food particles, vibrate electron present in the food particle. That's why micro oven heat the food and uniformly without heating the container. Without heating container, it cook the food. Medical application. There are different type of medical application where you use microwave. It means, as you can say here, microwave heating property also use medical, and such as diagnosis and various therapies also uses microwave, and for the diagnosis they also use microwave. Now Waveguide. Now we discuss what is waveguide. Basically, waveguide means a structure that guided the waves, known as the waveguide. A structure that guide the waves, known as the waveguide. Means the structure that guide the waves, that guide the electromagnetic wave. A structure that guide the electromagnetic waves, means electromagnetic wave propagate in the free space. They propagate a different direction in free space. But if we guide the waves in a particular direction, then with the help of a particular structure known as the waveguide. They are means here given here a hollow metallic tube of uniform cross section transmitting electromagnetic wave by successive reflection from inner walls of tube is called waveguide. Inside the waveguide, electromagnetic waves are propagated with the help of reflection through the inner wall, is known as waveguide. Microwaves propagate through microwave circuit. Microwave propagate through microwave circuit component and devices which act as a part of microwave transmission line, what we call waveguide. Next, waveguide is generally preferred in microwave communication. Waveguide is preferred for microwave communication. A waveguide is a special form of transmission line. Means waveguide is a special form of transmission line. Generally, transmission line use a lower frequencies, very high frequencies, but in microwave frequencies we use the waveguide. The waveguide is a hollow metallic tube. Unlike the transmission line, waveguide has no centric conductor. Okay? And the waveguide does not have centric conductor. Advantage of waveguide. What is the advantage of waveguide? This is also very important. And if we discuss about the waveguide, then we also want to know what is the advantage of waveguide. Basically, waveguide are easy to manufacture. They can handle very large power. Means the waveguide can be handle a high power, kilowatt power can be transmitted. Power loss is very negligible in waveguide. In the waveguide, there is very low losses because its inner layer is perfect conductor. It is designed in the inner layer of the waveguide is designed by the perfect conductor. Although in the practically there is no perfect conductor, but the waveguide inner conductor means inner layer is a designed by a good conducting material. They offer very low loss, low value of alpha attenuation. Means alpha attenuation means alpha and gamma. Suppose here gamma is the propagation constant, alpha plus j beta. Alpha plus j beta. Alpha plus j beta. Beta. Yes, beta. That is beta. Means here low value of alpha. This one is the indicator low value of alpha. It means attenuation. This one is where the attenuation is mentioned. This one is the attenuation. Alpha is the attenuation. And beta is the phase constant. When the wave propagate, then phase changes. If there is no loss, then the value of alpha is 0. If there is no loss, then value of alpha is 0. And there is some losses, then the alpha having the low value. Means low losses, alpha having the low value. Alpha means attenuation constant. The microwave energy which travels through the waveguide experience low losses than a coaxial cable. In compared to the coaxial cable, microwave waveguide having the low losses. Microwave energy having traveled through the waveguide experience low losses compared to the coaxial cable. Compared to coaxial cable, waveguide having the low losses. Type of waveguide. There are different type of waveguide. I will discuss here type of waveguide. This one is the type of waveguide. There are basically 5 type of waveguide. One is rectangular waveguide, circular waveguide, elliptical waveguide, single ridged waveguide, double ridged waveguide. Mostly we use a rectangular waveguide. Then after we use the circular waveguide. In the microwave lab, you can see that there is microwave test bench, and in the microwave test bench there we use rectangular waveguide. Now these are the different type of waveguide. This one is the rectangular waveguide. This one is the rectangular waveguide. Wave enter from here. And this one is the circular waveguide, top view, elliptical waveguide, double ridged waveguide, and the single ridged waveguide. These are the different waveguides. Transmission line versus waveguide. Transmission line. The main difference between transmission line and a waveguide are: what is the main difference between the transmission and the waveguide? The main difference between transmission and waveguide is two conductor structure that support the TEM wave is transmission line. Means transmission line consists two conducting layers. Transmission line having two conducting layers, but waveguide is designed by whole structure is designed by conducting material. There are different type of waveguide as discussed in the previous slide, and one conductor structure that can support T is very important. One conductor structure that can support T waves, and TM waves, but not the TM waves for the waveguide. This are the T, TM, and TM mode we discuss in the further slide. Here we only discuss the waveguide support the TE and TM mode, but it is not supported the TEM waves. Basically, transmission line supported the TEM. Transmission line support the TEM waves. Transmission line support the TEM waves, but inside the waveguide only TE wave. These are the modes, TE modes and TM modes. In the waveguide, basically TE and T or TM mode are exist, but in the waveguide there TM mode does not exist. TE mode only exists in the transmission line or free space. These are the differences between the transmission line and the waveguide. Between the transmission line and waveguide, these are differences. There are following differences. One is it support TEM waves. TEM waves, basically TEM wave is the pattern of transverse electromagnetic wave. But in the waveguide, TEM mode or TEM wave does not exist. It is not supported TEM mode. Waveguide does not support. All frequency can pass through the transmission line. And in the transmission line, all the frequency can be transmitted. Only frequency that are greater than the cutoff frequency can be passed through. Means waveguide work as a high pass filter. It is very important to note. Waveguide work as a high pass filter. Means below the cutoff frequency, the wave frequency is not travel inside the waveguide. Only the frequency, you can again see the only frequency that are greater than the cutoff frequency. Only frequency that is greater than the cutoff frequency can pass through the waveguide. Transmission line. Only one conductor transmission, two conductor transmission. Reflector or less reflection. Waveguide reflect to the inside the waveguide. There is a reflection or takes place. Suppose this one is the waveguide. Suppose this is the wall of waveguide, and there is reflection is takes place. Yeah, reflection is takes place. Here the waveguide, and there is reflection is here. Reflection is takes place. Reflection is takes place. Reflection is takes place. Reflection is takes place. Reflection is takes place inside the waveguide. This one is the waveguide. Waveguide. This one is the waveguide. This one is the waveguide. Reflection. This one is the indicate the reflection. The dotted are indicate the reflection. It has characteristics. It has characteristic impedance. It has wave impedance. Waveguide impedance. It has the characteristic impedance. Generally, coaxial cable, as we know that coaxial cable having characteristic impedance. Coaxial cable consider characteristic impedance. Generally, it is represented by Z0. For the coaxial cable, we generally use for 50 ohm coaxial cable. I think there is also a 70 ohm. I think 70 ohm coaxial cable also available in the market. 70 ohm, I think 70 or 77. I think 70 ohm coaxial cable also available in the market. Generally, we use 50 ohm coaxial cable. As you can see in the from your dish TV antenna to set-top box, you use coaxial cable. Coaxial cable, and it has the waveguide impedance. It has the waveguide impedance. Characteristic impedance of we also calculate the characteristic impedance of the transmission line with the help of the formula. Characteristic impedance Z not equal to ZL minus Z not ZL. It is a different thing. Now here we discuss the transmission line consider the characteristic impedance and waveguide just wave impedance. And propagation of wave is according to circuit theory. The working principle of the transmission line we calculate with the help of circuit theory. The working principle, working behavior of transmission line we calculate with the circuit theory. But the propagation of wave inside the waveguide. Inside the waveguide, we calculate with the help of field theory. This is also important. The behavior of transmission line we calculate with the help of circuit theory. Circuit theory means RLC. With the help of RLC parameters. But the propagation of wave inside the waveguide we calculate with the help of wave field theory. It has return conductor to the earth. Return conductor is not required at the body of waveguide act as a earth. In the transmission line, earthing is required. In case of waveguide, earthing is not required. Yeah, it is also important point. Waveguide bandwidth is not limited for the transmission line. Their bandwidth is not limited. That's why in the transmission line we can transmit all the signal. But in the waveguide, it works as a high pass filter, and means below the cutoff frequency. Below the cutoff frequency, the wave cannot be propagated. It works as a high pass filter. Wave do not disperse, and wave get dispersed. Is also important point for the waveguide. and the transmission line. Now, in the previous slide, we discussed a different type of waveguide. Here we discuss the rectangular waveguide. This one is the rectangular waveguide. This is also very important, and it is most widely used rectangular waveguide. This rectangular waveguide we discuss in the next class. Thank you.